Hey there, y'all. Today we're going to be learning about section 5.13, which is about reducing urban runoff. Learning objective for today is that you can describe methods for mitigating problems related to urban runoff. And remember that mitigate means to reduce. And the essential knowledge that you're going to gain is some of the different methods that we can use to increase water infiltration and kind of mitigate some of these problems with our traditional like pavement, permeable surfaces that come with urban areas. So we're first going to recap some of the environmental consequences of urban runoff. The first big one is the fact that we are going to have decreased infiltration into the ground, which is going to be a problem because we will not be having groundwater recharge and getting those aquifers and groundwater back up to their normal levels. We're kind of blocking the ability for the water to go through and do that. So if you look at this image here, if you look at how much infiltration can happen from a natural ground cover versus an urban ground cover, then that is going to be a large decrease in that infiltration. Now, one of the problems with this is that rain is going to come down and it's going to wash pollutants into storm drains and into local surface waters. And remember that water that goes into storm drains usually doesn't actually get treated. It just goes straight into the local body of water. So any pollutants that come with it end up usually just going straight into those surface waters. So if you look here, all the different things that could come from an urban area going straight down the drain, straight into the local. In this picture, it's the Chesapeake Bay. In our area, it's like the Puget Sound and the ocean. So we're going to talk about some of these pollutants and the effects that they can have. The first one is going to be salt, especially in the winter. In order to prevent icy roads, they spread salt on the roads in order to dissolve the ice and to make it more like gripping. It's a lot of chemistry, but it helps with ice. And when this salt gets pushed off into the storm drains, this is going to increase the salt content in the water that it ends up in, which can lead to plant and insect death. Additionally, you're going to have increased sediment also getting into this water, which is going to lead to turbidity, more cloudy water occurring, which is going to be a problem for those plants that do photosynthesis because now they've got a barrier to that sunlight coming through. Additionally, we've talked about this quite a few times, but fertilizer can then also run off, which leads to eutrophication because you get those algae blooms, which then are going to lead to more dying, and we are going to then have the bacteria breaking it down. Those bacteria are going to use oxygen, and just remember, eutrophication is going to lead to those algae blooms, which ultimately result in less oxygen in the water, which kills the organisms that need that oxygen. Then we also have pesticides. Pesticides are going to be part of this urban runoff, and it's going to end up killing non-target species who originally the pesticides weren't meant for. And lastly, we have oil and gasoline, which is going to come from all of the machines and cars that are going to drip that oil and gasoline can lead to suffocating the fish and killing aquatic insects. So here's going to be a solution to all of this runoff. It's going to be permeable pavement. And permeable pavement is specifically designed to allow stormwater to infiltrate and recharge the groundwater. So it can be things like pavers, or it can be more of like a gravel, or they even have like asphalt for roads that are permeable. And so it's actually like a ton of little like rock-like things that are made together, but it basically has cracks in it so that water can go through and make it down into the soil and the ground. What this is going to result in is it decreases runoff, which also decreases all those pollutants being carried into the storm drains and the local surface water. It's also going to decrease the likelihood of flooding during heavy rainfall. So you'll get less flooding on the roads because more of it's being able to go into the groundwater. Now, the big downside is the fact that it is way more costly than traditional pavement. So theoretically, if we were to go and just swap all of our roads for this, it would be a ridiculous amount of money. And so most cities feel like it just ends up not being worth it, and taxpayers often don't want to pay for it. So another solution that we have is a rain garden. And these are going to be gardens that are planted in urban areas, especially surrounding the storm drains. So this is going to give you an example of it. If we're going to have water that's like running off, it can go into this area, which we've got like a garden, and this is going to be an area where the water can actually get in contact with the ground so that it can start infiltrating it. Now, this is going to decrease runoff because it allows this to go and soak into the garden soil that surrounds the storm drain. So here's a better example of what it could look like in an urban environment. The water is going to go off of the road and straight into these areas. And eventually, although there's kind of a lot of water right now, that will end up soaking into the ground. So it's no longer just being trapped on the road and going straight into storm drains. This also is going to decrease the likelihood of flooding during heavy rainfall because, again, the water is not just sitting on top of this impermeable surface. It's able to go down into the ground. So this is going to be another example where ideally it's going to flow into the garden. And then you can have it set up so that an overflow will actually go into the storm drain eventually, but the main goal is to like get less and less in the storm drains and the roads and get more of it percolating down into the ground. Now, another benefit of this, besides just like actually looking nice, is it's going to create a habitat for pollinators. It's going to be like if you plant flowers and stuff, pollinators can have a source of where they're getting their pollen here. And it's also going to be a place that can store carbon dioxide in these plants and potential trees that are growing there. And it just, when I say it makes like a sense of place, people like this. Like they like walking by it and having some trees and greenery and not just all cement. So it helps people to be even like happier with these areas. Now, another solution is going to be public transit. So like using buses and using light rails and subways and stuff instead of driving yourself, because more cars on the road lead to quite a few problems. The first being cars are going to have more pollutants. You're going to get pollutants from the little bits of tires that break off. You're going to have oil that drips. You're going to have like antifreeze that can come off and stuff like that. And this is all different pollutants on the streets that are going to run off into storm drains and local waterways. There's some examples I just talked about, like motor oil and tire pieces. So if you look at this here and you just kind of look at the amount of area and how many people can be transported. So if this is the same grouping of people, this is how many cars it would take to move those people through a street. This is the amount of bikes and how much area it takes up. And then this is going to be a bus. So we're seeing that using your bike or a bus is going to be much better than all of these people sitting by themselves in cars. And another reason why public transit is great is because more cars is going to lead to more lanes and parking lots in order to transport and house these cars. And parking lots are going to be impervious surfaces that lead to more stormwater runoff. The more cars you have, the more roads and parking lots you need for them. So public transit is going to decrease runoff pollution. It's going to really decrease the pollutants from the road. It's going to decrease carbon emissions because instead of having like 50 cars on the road, you have one bus. And that one bus, sometimes it can be an electric bus and sometimes it can be more like a hybrid. But either way, it's going to be less carbon dioxide than all of these cars sitting there releasing their carbon dioxide. So here's kind of a fun way to think of it. Well, fun, it's a good reminder. When you are stuck in traffic, remember that you are the traffic. So this is my recommendation to try to find ways where you can take the bus, take public transit, ride your bike, or just find a more less polluting a less polluting solution to getting from point A to point B. Take public transit if you can. Another solution to our urban runoff is going to be building up, not building out. Building vertically is going to decrease the impervious surfaces, which then leads to decreased urban runoff. So this is going to be a picture of Atlanta versus Barcelona in Spain, Atlanta, Georgia, here in the United States. If you look at Atlanta, it's more of a sprawling area. You're going to have a lot of like single houses, a lot of roads, a lot of impervious surfaces. And if you look at the population, it's actually very comparable to what we have in Barcelona. Barcelona even has more. The urban area of Atlanta is going to be over 4,000 square kilometers versus in Barcelona, where they have a lot more of like apartments and condos and where you build up. They have an even greater population, but their urban area is only 162 square kilometers. And then if we look at the carbon emissions of these areas, especially think about how long it takes people to make it through this entire area, they're going to have way more carbon emissions for people traveling all throughout Atlanta versus Barcelona has way lower carbon emissions because in those tight areas, you're able to have better public transit. You're also able to have people walking places. And so this is just kind of like a map image of how when you plan a city to be more built up instead of out, there's a lot of ways that this can be more environmentally sustainable. Another thing that's cool about this is you can make it even more environmentally sustainable by combining it with green roofs or rooftop gardens to further decrease the runoff. So here's a pretty cool example where you either put gardens on the rooftop or you make kind of these like green roof areas. Sometimes it's just a flat roof where you have plants growing on top. It doesn't always have to be this like cool fancy garden area, but it can literally just be trees or plants on top, which is going to further decrease runoff and is also giving us more plants, which is good for decreasing carbon dioxide. Because green roofs are then going to sequester that carbon dioxide. They're also going to filter out air pollutants. Plants absorb all sorts of like nitrous oxide and particulate matter into their stomata, and they store it in their tissues and cells. So it's going to help with some of that urban pollution as well as the runoff. So you can double team it in this way and make it even better. Oh, here's just an image of the stomata and how they take in those pollutants. So here's going to be a practice FRQ for 5.13. And the suggested skill is that you get some practice with scientific experiments. So what I want you to do is to design an investigation to measure the relationship between the number of trees in a city and the amount of stormwater runoff that the city produces. So you're going to start with proposing a hypothesis for your investigation, like if blank increases/decreases, then blank will increase or decrease, something like that. I want you to briefly outline a procedure for your investigation, identify your independent variable, and identify your dependent variable. So that's going to be your practice FRQ for 5.13, and those were your notes on 5.13.